All right, we're going to hopefully finish up this lesson today, 6-2. Do you remember where we kind of ended up yesterday? We showed you that what's true on a parallelogram about the opposite sides. There's two things that are true about the parallelogram. They're congruent to each other, and we proved that yesterday, didn't we? All right, and they're also parallel. Why do we know they're parallel? Because of the what? Well, you almost said it. Because of the definition. It's not a theorem. They're parallel because of the definition of a parallelogram, okay? They're equal to each other in length because of a theorem. Everybody got that? If I had you guys doing proofs and writing out all the reasons and stuff for proofs, you would have to know all that stuff. So as long as I talk about it and you know it, I think that's good enough. So let's talk about one more. Well, we're going to talk about several things, but let's talk about another thing with this picture. Let me draw another line. It's the same thing as we did yesterday, all right? Except we showed that the triangles were congruent to each other. That means these opposite sides, right? They matched up with each other, so they have to equal each other, all right? And then these two sides matched up with each other, so they have to equal each other because the triangles are congruent. Because if I took one, sit it on top of the other one, all the sides would match up, wouldn't they? Yeah? Okay. So we know that. There's one more thing that we know. Look at BC and AD and the transversal. Yeah. Actually, I don't need that red line right there. Let's take a look at this. Look at BC and AD. Okay? They're not complementary. I think you're kind of onto it.
I was thinking about the transversal, how the opposite sides were.
See, these two are parallel to each other, right? And this is a transversal. Would you agree? So like if I drew it by itself, sometimes it helps drawing it by itself. There's the two parallel lines. The AB goes like, oops, a little squiggly. That's not even any better. Who cares? So it's a little squiggly right there. So if you got parallel lines, tell me something about A and B. Where would A and B? This would be B, wouldn't it? Yeah. And this one right here would be A. Yeah. Now, what's true about them? Are they equal to each other? Yeah. Are they? No, look, that's an obtuse. That's acute. There's no way they're equal to each other. But they do have a relationship. What's the relationship? Supplementary. They're supplementary, okay? So they do what? They add up to 180, all right? You could do the same thing with saying that this AB and CD are parallel, and this right here is a transversal. So what's true about B and C? They're supplementary. What's true about C and D? Supplementary. What's true about A and D? Supplementary. Okay, you follow me on that? Okay, so that means when you have a parallelogram, we call these the consecutive angles, just like we did right here when we did parallel lines cut by transversal. Okay, so this angle right here is supplementary to this angle right here. Now watch. I'm going to show you something else. So this angle right here is supplementary to this. If this has two arcs, what must this have then if they add up to 180? This and this add up to 180, and this add up to 180. So D must be the same as what? B. Would you agree? Yeah. So this one and this one add up to 180. So this has to have the two arcs. Would you agree? If they both add up to 180, all right? So for instance, if this was, 50 degrees right there, then this would be what? 130. If this is 130, what's this got to be? This has got to be 50. If this is 50, what's that got to be? It's got to be 130. Now, so that's actually one of our theorems. Let me see. Yeah, one of the theorems says that the consecutive angles of a parallelogram are supplementary. All right, so that means A and B are supplementary, A and D, C and D, B and C. All right, but you got another theorem from that theorem right there. They actually, yeah, it's a theorem, and it's not the next one, but it's the one after that in the book. You have another theorem that says the opposite angles of a parallelogram are what, do you think? The opposite angles. These are opposite angles. These are opposite angles. What's true? They're congruent to each other. That's right. Okay, they're equal to each other. So angle B and angle D would be equal. Angle A and angle C would be equal. All right? So that's a lot of stuff that you know about a parallelogram, isn't it? All right? And we kind of proved to you both of those things. We proved that the opposite sides are equal. So those two are equal. These two are equal. We proved that the consecutive angles are supplementary. And we also proved that the opposite angles are equal to each other. Yes, sir?
So like on a quiz, will we have to be able to prove
No, I'm not going to ask you to prove it. I'm just doing that because I think it's important. I think in math, it's important that a teacher doesn't just stand up here and just say, okay, this is true. I could have just come up here and said, this angle right here is equal to this angle. Just believe me, all right? I could have done that, and you could got the problems right, and everything would have been fine. But I think it's important that you see why that they're equal to each other. I can't do that on every single theorem that we do. Sometimes the proofs are really, really complicated, and I can't really go through it. So every once in a while, I may say, this is true, just believe it, all right? And that's fine. But I think when we can, I think when it's simple enough to see, I think it's a good idea to be able to prove that these things are true. Would you agree with that? Yeah. I think that's good in life with anything, right? If you had an argument with somebody, not like a mean argument, but if you were debating somebody on an issue, you'd want to have facts to back up your thoughts, wouldn't you? Right? Do you talk about that in Bible class? You ever talk about like sharing your faith with somebody and having facts to back it up and things like that? Maybe in history class, I don't know, something like that. You could probably talk about it. But I think it's very important that you do have those things to back it up. And you're right, Ben. Facts, not feelings. I know where you're getting that from. But I won't get political here, so. All right, but I think that's true no matter what your politics is. I think it's true in any case. All right, let's do another one. What if you had a parallelogram that had one right angle? If you had a parallelogram that had one right angle, just picture it in your head. You could have a rhombus that has one right angle, but then it would be something else as well. It wouldn't be a kite. A kite, I know you like the kite, but the kite really is it's by itself, right? That's basically, the kite, the only thing a kite is a quadrilateral. Okay? So if you had, think of it, I want you to think. If you had a parallelogram and one of the angles was a right angle, tell me something else about the other angles. What'd you say? They all have to be right angles. Why is that?
Because they have to equal to 180.
Exactly right. They got to be equal to 180. Let's go back to white on this. So watch. Would you agree that this could be a parallelogram? Yeah, it could be. If these two sides are parallel to each other and these two sides are parallel to each other, it's a parallelogram, right? But it also looks like a what? Looks like a rectangle because that angle right there. Now let's listen. Shh. All right. We had a sneeze and a cough. Everybody does it. Okay, we don't have to go crazy over it. All right. So watch. This is a parallelogram, agreed, with one right angle. But that means that the others have to be right angles. Why is that? Because the opposite angles are equal to each other, right? So if that's a right angle, then that has to be a right angle. The consecutive angles have to be supplementary. So if this is 90 degrees, then 180 minus 90 is 90. So that has to be 90 degrees. I will. And then if this angle is 90, then the opposite angles are equal. So would you agree? Just knowing that one of those angles was 90 degrees, that makes all the other ones have to be 90 degrees. So if you have one right angle, then the thing has to be a what, more specifically? Square. It's not always have to be a square. This isn't a square. Yeah, but more specific than a parallelogram. Okay. What is this thing? Thank you. It's a rectangle. All right? It's a rectangle. So if you have a parallelogram, we know it's a parallelogram to begin with, okay? If you have a parallelogram with one right angle, then it has to be a rectangle. Okay, enough of that. It is. You're right. It is kind of simple. All right, let's do another one. And I don't think I'm going to... well, it could be a square, but you can't specifically say a square because it's only a square if all four sides are equal to each other. Okay? But if a square is a rectangle, correct? No, you can every rectangle. You have to say every rectangle is not a square. You can't just say a rectangle because a rectangle could be a square. Okay, but if you said every rectangle is a square, that's incorrect, right? But you can say every square, what, is a rectangle. And also every square is a parallelogram, and every square is a, what's the one word you always wanted to say? A rhombus, not a kite. Remember, a kite is only a kite, all right? It's not a parallelogram. It's only a kite, and it's only a quadrilateral. It's not a rhombus. It's not a parallelogram. It's not any of that. All right, enough of that. We're wasting too much time. Let's keep going. Here, I got another one. Let's draw a parallelogram. I'm not going to prove this one. There we go. All right, I got a parallelogram here, and what I want to do, and let's do this. Let's click off of that. Let's change this. Make this a different color.
Oh, that's a
Okay. So watch. You've seen this before. If I could get, there we go. Somebody get it. Everybody look. I want you to see something. Now, I just talked about proving stuff, but I'm not going to prove this. I'm just going to show it to you, okay? So I hope you're okay with that. Let's go back to white. All right. What do we call these? When you go from one vertex to another vertex like this, it's not a transversal. It starts with a D. It's a diagonal. Remember we talked about that when we did those polygons? Shh, listen. Do you remember when we did those polygons and we started at one vertex and we went to all the other vertices? Okay, those are called diagonals. So these both are diagonals, right? Now, there is a relationship between these diagonals. Now, just by looking at it. Now, this is not very geometric of me to say this, but just by looking at it, do they look like they're equal to each other?
Yeah.
They do?
No.
Now, that yellow one looks way what?
Shorter.
Yeah, it looks way smaller, shorter than the red one. Would you agree? Yeah. Now, that's not a good geometry way to say it just looks like it. But, again, we're not going to prove this one, okay? I'm just going to show it to you. So they're not equal to each other, but they do something. Where they hit, where they intersect right here, you actually have formed, let's just do this, A, B, C, D, and I'll call this M for a reason. All right? Right here where they hit each other, what does it look like? Again, just looking, AM and CM. It looks like it's in the middle, doesn't it? Okay, well, no, it's not central. Say it. No, there's no in-center because this is not a triangle. We only have in-center when you have a triangle, okay? But it looks like it's the midpoint, doesn't it?
Yes.
Now do you understand why I call it M? Okay, because it's the midpoint. So it is. All right, so M is the midpoint of AC, and also, what do you think? M is also the midpoint of BD. That's right. So here's what the theorem says. If this is the midpoint, the theorem says that these diagonals do something to each other. Okay, we've used this word before. It hits at the midpoint on both of them. Starts with a B. Any idea? Bisect. Very good. Bisect. Okay, they bisect each other. I'm not going to write it down. You can write it down if you want. But the theorem says that the diagonals of a parallelogram bisect each other. You hear me? So that means that this and this are equal, and what? BM and DM are equal to each other. Now, I didn't put just one arc because all four are not equal to each other. You follow me? All right, because this red one right here is longer than this yellow one right here. So they're not all four equal to each other, but they do bisect each other. So that's very, very important. So if I told you that AM was 5, what would MC be equal to? It would be 5. What if I told you that BD was 8? BD was 8. What would BM be equal to? 4. Exactly. You with me on that?
Yeah.
Okay. Right. Because it's half. That's right. Because it bisects it. Splits it in the middle. Pretty easy, right? It's just something you got to remember. They're going to give you questions like that. But they're going to go even beyond just putting just numbers there. What do you think they're going to put there? Yeah, equations with like x's and y's and stuff like that, okay? So they're going to put algebra equations. So you would set, this one equal to this one, solve for x, plug it back in, right? We've been doing that most of the year, haven't we? All right? And that's a big part of geometry, is taking the geometry part of it, turning it into algebra and then solving for x or whatever they ask you to solve for. All right, let's see what else we have. I think that's all the new stuff. We just have examples, though. So let's draw this one out. This is in the book. It's example 1. And let me make this look like that. Oops.
Wait, it's saying yes to something, it's saying no to something.
All right, everybody watch. You should draw this. So everybody should be drawing this. You should be taking notes on this. So this is example 1. And we're going to put a bunch of stuff in here. Tell you what, I'll just look right here. So this length right there, they put meters, 6.3 meters. I'm not going to bother putting the little meter thing there. It just kind of gets in the way, I think. All right, but that's 6.3. That's the length of that. This one right here is 4.2. By the way, they call this E because life is full of decimals. Life's not always even numbers or whole numbers. What's the quote? Life is full of decimals? Okay. Oh, okay. Probably should. All right, here we go. I didn't leave myself much room here to write stuff. Let me scooch it up a little bit. All right, so what do they ask for? So part A asks to find DC. All right, so this is, by the way, they tell you this is a parallelogram. Okay, it says find the lengths of each measure. Oh, they tell you something else too. Sorry about that. They tell you that angle ABC, that whole angle right here is 72 degrees. So what do you think we're going to do? If that whole angle right there is 72 degrees, let's find that little angle right there. So what would that be?
72 plus 41 or minus 41?
You subtract. The whole thing is 72. This is 41. You find out what's left over. How do you find what's left over? You subtract. So it'd be 31, wouldn't it? Agreed? All right, and they tell you one more thing. Shh, listen now. They tell you that BD is 11.6. BD, from here all the way to here is 11.6. It's not that funny. So what do you think you're going to find? If they tell you that BD is 11.6, what do you think you're going to do with that? Cut it in half, exactly right. And so what is half of it? 5.8? Okay, so that would be 5.8. And what else? That would be 5.8. We good? Okay. So that's all the stuff they tell you. They tell you a lot of stuff, all right? But they're going to ask you a lot of stuff as well. And it's really not that hard. If you know the stuff that we just talked about, it's really not that difficult at all. Yeah. Yes, AB would equal CD. Exactly right. So look at the first problem. It says find DC, which is this right here. So how in the world do I find this? It's 6.3, right? Because the opposite sides are equal to each other. So if you know your theorems, then it works out pretty nice and easy. So that's, well, let's just go in order. Let's just do what they ask in here. So they ask for B, they ask for EC. Well, EC, this one right here. How do I find that one right there?
You double it up too.
Do you double it?
No, you just use 4.2.
It's EC, just from here to here. Right, it's 4.2. It's the same from A to E, right? So this is 4.2. Now, if they ask, they might. Do they ask? They don't. But if they ask for AC, then you would have doubled it. Everybody see that? All right, so EC is 4.2. That's easy. C is ED. The length of ED. ED. Oh, we already found it, right? Because we already took half of that 11.6. So that was good. So we got C. And then letter D is angle DAB. Angle DAB. DAB. All right, DAB. So we're finding this whole thing right there.
180 minus 63.
Minus 63?
It's going to be a little over 90.
63?
No, it wouldn't.
Remember, this whole thing right here is 72. From what? Minus from what?
108. The answer's 108.
Minus 180. Right, that's what I was looking for. It's 180 minus the 72. Right? And then what's that? 108? Okay, so that would be 108. Do you see that? Because look, remember the listen, I'm trying to explain this. These right here, the consecutive angles are supplementary, right? So if that whole thing was 72, which they told you earlier, it was 72, then this is 180 minus 72. Okay? Yep. So this there's a lot of stuff going on here, but that's 108. Okay? E. ADC, angle ADC. Where's ADC? ADC. So that's this whole big angle right there. Without doing any math at all, what is it? Well, without doing any math, though. Without doing any math. 72. Why? You could subtract it from 108, but you've already got it right here. Remember, the opposite angles of a parallelogram are equal to each other. So this angle right here, this whole big angle is equal to this whole big angle. And so if that's 72, then this is 72. Okay. One more, and then I'll let you go. Hold on. DAC. Watch. DAC. DAC. That's this little one right here. What's that going to be? No, it's not going to be 63 because watch. This is 63, then this one right here is 63, and this is going to be what? 108 minus 63, and that's 45 degrees. Okay, you do have homework, okay? You have your lesson plan, right? It's got it on there. I'll write it on here as you guys leave, okay? So you do have homework, so make sure you get that done for Monday. Have a good weekend, and as always, go Birds. There's a little bit we still didn't cover, but we got most of it. You should be able to do most of this. So it's section 6.2.
Yes.
I had a student just ask me if we had homework or not. Can you believe that? 1 through 17 and 21. Yeah, go ahead. You don't have your lesson plan thing?
Oh, I don't think it didn't say that. It just said finish worksheet.
No, it has it on there for Friday. I'm
thinking it's Thursday.
looking at it.
That's
Yeah.
on there.
All right, that's it.